Hi dear students. So today we will discuss our last topic in chemical kinetics, that is the integrated rate equation for a first order gas phase reaction. So we have already discussed the integrated rate equation for a first order reaction where all the reactants are in concentration. You remember. Okay. Now we say it is a gas phase reaction. That means the reactant is in gaseous state and the products formed are also in gaseous state. We know that from states of matter or the gas equation PV is equal to nRT. Now here the biggest doubt students ask is, sir, instead of concentration, how you are considering here pressure? The answer for that is, if you see here, I can rearrange this equation as P is equal to N by V into R into T. So we know that N by V is nothing but number of moles of the initial reactants by volume taken is nothing but concentration. Correct? Concentration C. So this we already learned in the chapter solutions. So we know that this is concentration. So we can write this equation as P is equal to concentration into R into T. Now let's say we can say for a reaction, T is a constant. T is a constant. We are maintaining the temperature as constant. We already know R is also a constant, that is called gas constant. So if these two are constant, we can say pressure is directly proportional to C, that is concentration. So where and all you are using the concentration term, there and all I can use pressure instead. Correct? So let's rewrite the equation one more time. That is A, which is in gaseous state, it's getting converted to B and C. These two are also in gaseous state. Okay. So let us assume Pi is the initial pressure. Pi is the initial pressure. That means when you are taking the reactant, the initial pressure of the medium is Pi. Initial pressure. Okay. Now, so Pi be the initial pressure means initially only reactant A is there. So we can say it is the initial pressure of A. Only reactant is there. Correct? And let PT be the total pressure. PT represents the total pressure. Okay. So when PT represents the total pressure, maybe at time T. Why we are saying at time T? Because after some time T, B and C will also form. Then the pressure of B and C also needs to take, we need to consider into account. So the total pressure at that point of time will be PT. So I can say the total pressure PT will be, we already learned Dalton's law of partial pressures. So we can say it is the sum of partial pressure of A at that point of time, B and C. So many students will ask here, sir, why we need to write A here? Because the products are formed. I am talking about a stage intermediate in between. That is, the complete A has not converted into B and C. Only some moles of A gets converted into B and C. So there will be some amount of reactant A remaining. So that will exert a pressure that is called PA. Then this is the pressure exerted by the product formed PB, and PC is the pressure exerted by the product C. Okay, so we understood PT is nothing but PA plus PB plus PC. Now let's say maybe we will say at time T is equal to 0. I will take another color. Okay, so at time T is equal to 0. Tell me, only reactant molecules are there, right? So if I rewrite the equation, A gas giving B gas plus C gas. In this case, I know that the initial pressure is only available. So say we say Pi atmosphere, and we know that B and C are not formed at that point of time. So there will be no pressure. So we put 0 atmosphere there. Correct? Now we know that at time T, after time T. So we say at time T is equal to T. That means 0 to T. Time has gone out. Now what has happened? Some amount of A has been converted to B. Correct? So we say the pressure, if the concentration of A is decreased, surely the pressure exerted by the A reactant will also decrease. We know, right? Partial pressure is equal to total pressure into mole fraction of that particular component. So if the mole fraction decreases, why mole fraction is decreasing? Because the number of moles of A gets converted to B. So we know that the pressure exerted by A will also decrease. So let's say it has decreased X atmosphere. So we say Pi minus X is the new pressure. Now we know that X atmosphere is decreased means the same amount of pressure will be increased from B and C side. So this will be X atmosphere and this will be X atmosphere. Why it is like that? Because 1 mole of A will give 1 mole of B and 1 mole of C. So I can say that if 1 mole of A is decreased, surely 1 mole of B and 1 mole of C has formed. So 1 mole of A corresponds to X atmosphere means surely for B and C it will generate X atmosphere in the reaction medium. Correct? So now let us calculate the total pressure at time t. So the PT, total pressure at time, is equal to T. What will be the total pressure? Pi minus X plus X plus X. Correct? So this, if you add it, you will get it as PT is equal to, this will get cancels off and this will become Pi plus X. Now can you tell me what is X here? I can say X here is PT minus Pi. Correct? PT minus Pi. Now, now we say, what is the integrated rate equation we have already learned? You might be remembering. K is equal to 2.303 by T log, correct? Log initial concentration here is mapped to pressure, so say initial pressure divided by final pressure of the reactant. We say all the rate equation with respect to reactants only, correct? So the final pressure of reactant, that is Pa, pressure exerted by A alone. So what is Pi? So we can substitute for Pi will be initial pressure, that is Pi itself. What is Pa? We know that Pa we already know, okay, that is Pa is equal to Pa is equal to Pi minus of X. But we already know the value for X, so let us substitute that. So that is Pi minus of Pt minus Pi. So we know that this will become Pi minus Pt plus Pi. So that is nothing but 2Pi minus Pt. That is what is Pa. Correct? So we can substitute this equation 2 in equation 1. So we will get the integrated rate equation for a first order gas phase reaction. K is equal to 2.303 divided by T log Pi divided by Pa. Pa is 2Pi minus Pt. So this is the final equation. You should remember. It's very important. These days they are asking this equation. So they will give a gaseous phase reaction and ask you to find out the rate constant for first order gas phase reaction. I hope you understood. If you have any doubt, feel free to put the doubt in the doubt clearance group. Thank you. So hi dear students, so we have a new question in front of you. This question is based on what we have discussed now. That is, it's based on first order, it's based on integrated rate equation for first order gas phase reaction. Okay, so we will read the question. The following data, okay, I will highlight it. The following data were obtained during the first thermal decomposition of N2O5 at constant volume. 2N2O5 giving 2N2O4 plus O2. Now if you see here, you can see that initially the time the total pressure was 0.5. We know that this is due to the reactant N2O5. Now after 100 seconds, we could see that the total pressure increased to 0.512. We know that at that point of time N2O5, N2O4 and O2 is there. Now the most important thing for you to remember here is we cannot directly by heart the equation and apply here. We need to do it in the same way as we have derived the equation, because every time the stoichiometry of the equation will be different every time. So based on that, we need to change the equation as well. For example, let's see how to do this question. Now I will rewrite the equation. 2 n2 of 5, which is in gaseous state, correct, it is getting converted to 2 n2 of 4, which is also in gaseous state, plus oxygen, which is also in gaseous state. Now if you see here, as per stoichiometry, 2 mole, correct, 2 mole of n2o5 is giving me 2 mole of n2o4 and 1 mole of oxygen, correct. Now now let's see starting time at t is equal to 0. At a time t is equal to 0, we know that the total pressure is zero point 0.5 atmosphere. So that means the zero point 0.5 atmosphere is due to N2O5, correct, because only reactant were present initially. So there is pressure of N2O4 and oxygen is 0 atmosphere, correct, because they were not present at that point of time. Now we say at time t is equal to 100 second. That is what given in the question. Okay, so in 100 second what happened, as per the stoichiometry, we know that 2 moles of this will give you 2 moles of N2O4 and 1 mole of O2. So we say that zero point 0.5 was the pressure, that minus 2x. Why I am taking 2x? Because if we, x is the atmosphere for 1 mole, suppose 2 moles are uh, converted to this, means we know that the pressure we need to 2 moles are converted, means we know that that much amount of number of moles is decreased. So we know that number of moles is proportional to the pressure, correct, concentration is directly proportional to the pressure. So we say that much amount of pressure is also decreased. Okay, so if 2x is decreased here, then we know that 2x atmosphere pressure is increased due to N2O4, because 2 moles of N2O4 is formed. Then due to that 2 mole of N2O4, 2x atmosphere will be there in the reaction medium, and 1 mole of O2 means here it will become x atmosphere, correct. So we got this equation. Now what we need to do, now we can calculate the total pressure. Okay, so let's say the total pressure. Okay, so the total pressure, I will take a new color. So the total pressure PT is equal to, tell me, pressure due to N2O5, correct, pressure due to N2O4 plus pressure due to oxygen, combination of this, correct. Now pressure due to N2O5, how much it will be after 100 second? You know that it is 0.5 minus 2x. We know that just now we have done here. Now pressure due to N2O4, it is 2x, and due to oxygen it is x. Now if we are opening the bracket, we know that this will get cancels off. So this will become zero point 0.5 plus x pt. Now I know that x will be what actually? Pt minus 0.5, correct. Now I got x value. Now we know that at a time t is equal to 100 second, at a time t is equal to 100 second, what was the total pressure pt given in the question? Pt given in the question is 0.512 atmosphere, 0.512 atmosphere. So we can substitute that here to find out the actual x value. Okay, yeah, so let's see that. So p, we say pressure due to N2O5 is equal to, what is that equation, pressure due to N2O5? Let's see that. Okay, so the pressure due to N2O5, we will get it now. Okay, that is zero point 0.5 minus, due to N2O5 is 0.5 minus 2x, correct. So that is 0.5 minus 2x means we will do it like that, 0.5 minus 2 times x. X we already know, pt minus zero point 0.5. Correct? So 0.5 minus 2pt minus of minus plus 1. 2 into 1 by 2. That is 1. Now we can do it further. How it will become? We know that 1 plus zero point 0.5 is 1.5 minus 2 times p into t. Pt is 0.512. We already know that total pressure. So if you calculate this, you will get the value of p n2 of 5 after 100 second. And if you calculate this value will come around 0.476 atmosphere. Okay. Now we will use our standard equation K is equal to 2.303 by T, correct? Log initial concentration by final concentration. Okay, we say here PF and we will substitute. So 2.303 by time is 100 second, log initial concentration. Initial pressure was which one? You might be knowing it from the question, correct? So question it is given there, the initial pressure was 0.5 atmosphere, you remember. Okay, so let's substitute that here, 0.5 atmosphere, and the pressure of the reactant after 100 second, that we calculated it as 0.476 atmosphere. So 0.476 atmosphere, correct? So let's now substitute the values and find the answer. So 2.303 by 100 into log zero point 0.5 by log zero point 0.4. So that is log 5 minus log 4. So this will come around 0.0216. So what will be the value if you multiply this one? So you will get an answer that is 4.98 into 10 power minus 4 second raised to minus 1, since it is a first order gas phase reaction. So 4.98 means approximately what we can say, it is 5 into 10 power minus 4 second raised to minus 1. I hope you understood the question. So please remember, try to do the question in the same way rather than by hearting the formula. Okay, so that will help you to crack the NEET exam in a much better way. Thank you. So I will just read the question, highlight the question. Which of the following will react at the highest rate? Okay. So you have options like 1 mole of A and 1 mole of B, 1 mole of, I will use another color, 1 mole of A and 1 mole of B in 1 liter vessel, 2 mole of A and 2 mole of B in a 2 liter vessel, and 3 mole of A and 3 mole of B in a 3 liter vessel. All would react at the same rate. So what do you feel as the correct answer? So let's try it out. So we know that they want to know which of the following will react at the highest rate, correct? So this is what they need to know. So let's see whether all have. So here taking the option A. Okay. So I'm going with the option A. So here 1 mole of A and 1 mole of B is present. We say 1 mole of A, 1 mole of A and 1 mole of B is present here. 1 mole of B. And this is a 1 liter vessel. So now tell me what is the concentration. We know that the rate of a reaction is proportional to concentration of the reactant. Concentration of the reactant. Correct? We know this. Reactant. Concentration of the reactant. Now what is concentration of the reactant? Concentration of the reactant is equal to, tell me, number of moles of the reactant, number of moles of reactant divided by volume, volume in which this reactant is present. Now let's see here, In the first case, what is the number of moles? You have 1 mole of A and 1 mole of B. So total 1 plus 1, 2 divided by 1. That is the volume of the container. So that is 2. So the concentration of the reactant is 2 mole per liter. Correct? Now similarly, we will go with the option B. In option B, what is present? 2 mole of A and 2 mole of B. So 2 mole of A and 2 mole of B means concentration of the reactant is equal to number of moles of the reactant, that is 2 mole of A and 2 mole of B, divided by volume of the vessel, that is 2 liter vessel. So we put 2, so that means 4 by 2, that is 2 mole per liter here also. Then what about the third case? They are telling the concentration of the reactant here is equal to how much? They are keeping it as, we will see, 3 mole of A and 3 mole of B, 3 mole of A and 3 mole of B in a 3 liter vessel. So that is 6 by 3, that is again it is 2 mole per liter. So that means rate is proportional to concentration, and in every case concentration is what? 2 mole per liter. So that means all will react at the same rate. So what should be the answer here? All would react at the same rate. I hope you understood the question. If you have any doubt, please get back to us in our doubt clearance group. Thank you. You have a new question in front of you, so let's try to read the question. Question here is, at least how many half-lives should elapse for a first order reaction where A is getting converted to products so that the reaction is at least 95% completed? So how to do this question? So they are asking you, it is a first order reaction. So they want to know in the reaction A, which is getting converted to products. Okay, A is getting converted to products. So they need to know when 95% is completed of the total reactions, 95% is completed, how many half-lives should have elapsed? So there is an easy method to do this. Let's see how it is. So I say initially 100% was there. Okay, so when this 100%, when it becomes 50%, so we know the definition of half-life, the time required for the reactant to become half of the initial concentration, that is called my half-life definition. So 100% becomes 50% means one half-life is used. So from 50% to 25%, we can say the next half-life is used, and from 25 percentage to the next half means 12.5 percentage, we have the third half life being used, and from 12 percentage to how much its half will be? 6, correct? 6.25. So if it is 6.25, another half life is used, correct? So until now how much is totally consumed? So if you see here, we can see like 6.25% is now happened. That means up to 94%, but they are asking 95%. Now only 6.25% is remaining. That means 100 minus 6.25% is already completed. That means we can say already, we can say how much? If it is 6 means 100 minus 6 is 94. So 6.25 means we can say 94.75 is completed. So but they are asking you how much t half would be taken if 95% needs to be completed. So we know that one more t half is required for completing 95%. So that means another t half means this will become 3.125. So that means what actually? So now only 3.125 is remaining, that is 100 minus 3.125, that is it has crossed the 95%. So how much t half it has taken? 1, correct? I can calculate like this: 1, 2, then 3, then 4, then 5. So after 5 t half, the initial concentration, that is 100% of the reactants, now what is remaining? remaining is only 3.125 percentage reactant is only remaining. That is 95 percentage of the reactant has underwent reaction and the reaction is completed. For that, minimum how many t half is utilized? 5 t half is utilized. So the answer is 5. I hope you got an idea how to do this question. If you have any doubt, get back to us in doubt clearance group. Hi, we have a new question in front of you. Just read the question. The T half for a first order reaction is found to be 2 minutes. The percentage of the reactant left after 360 seconds is. So this is the question. So let me say it's a first order reaction and they have given the T half as how much? T half is equal to 2 minutes, right? So if it is 2 minutes means how much second it is? 1 minute is 60 seconds. So 2 minute is 120 seconds. Okay. Now they are asking you the percentage of the reactant that is left after 360 seconds after. So that means we can find out 360 seconds is equal to how much T half. So we say 1 T half is equivalent to 120 second. Correct? So let's convert this 120 to 360. So 360 to 360, I can say multiply by 3. So here also I will multiply by 3. So I will get the answer as it is equivalent to 3 T half. So we know that initially 100 percentage was present. So after that first T half is applied, then this becomes 50 percentage. Now the next T half is applied, so this becomes 75 percentage. Sorry, not 75, 25 percentage. It was wrong. Okay, so it is 25 percentage. Correct. Now we apply the third T half, so this becomes how much? 12.5 percentage. So that means each T half is applied means you are applying 120 seconds. Correct. So that means after 120 seconds the reactant becomes 50 percentage. Correct. Then another 120 second, that means after 240 second the reactant is becoming only 25 percentage is remaining. Then after another 120 second, that is after 360 seconds, only 12.5 percent of the reactant is remaining. That means remaining has already underwent reaction and converted to products. So the percentage of the reactant left, they are asking you what is left behind. So the answer is 12.5 percentage of the reactant is left behind. Understood? This we can, and you can see here, this we are applying mainly if it is a first order reaction. Okay, so I hope you understood the explanation, and if you have any doubt, feel free to come back. So we have a new question in front of you. So let's read the question. T half of a first order reaction is given as 0.693 divided by K. The T 3 by 4 would be equal to for the same reaction. So we know that for a first order reaction they have given the T half as T half is equal to 0.693 divided by K. Correct? And they are asking you T3 by 4. So what is T3 by 4? Basically 75 percentage. Correct? And T half we know it is nothing but 50 percentage. And they are asking you for T3 by 4 what is the value? This is the question. So we know it's a first order reaction. So we know that 100 percentage initially was there. So on applying the T half, this will become how much? 50 percentage. Correct. So if I do T half one more time, this will become what? I actually 25 percentage. So that means 100 percentage of reactant was present initially. Now it is becoming 25 percent of the reactant. That means what? Actually 75, around 75 percentage of the reactant gets converted to product. Correct. So that is T3 by 4. So T3 by 4 is what? Actually the amount of time which is required for the reaction, for the reactant to complete 75 percentage of the reaction, or 75 percent of the the time required for the reactant to become 75% of the initial value. Now you know that initially 100% was there. Now 75% of the reactant is getting reacted. So that is how many t half it has taken. You could see here 2 t half is taken. So we can conclude the formula saying that t 75% is nothing but 2 times, because it is taking 2 t half, 2 times t half, or 2 times t 50 percentage, correct? So what is the value then? 2 into what is t half given here? 0.693 by k. So if you multiply this, you will get zero point 0.6 into 2, that is 1 point some 2. So since 693 is there, it will be 1.386, 1.386 divided by k. That will be the answer. Okay, clear. So I will write one more time in another color. So very simple. So we can conclude saying that for every first order reaction, t 3 by 4 is 2 times t half. Understood? So 2 into 0.693 by k, correct? So this is equal to 1.386 by k. So let's see whether this answer is present here or not. Yeah, it is present as option C. So option C is the correct answer. If you have any doubt, feel free to ask in the doubt clearance group. Thank you. Hi dear students, we have a new good question in front of you. So I will just read the question. The question is very simple. The plot of log k versus 1 by t helps to calculate. So this is the question. So first of all, we need to know here log k versus 1 by t is given by which plot. We know that according to Arrhenius equation. Okay, according to Arrhenius equation, what is the Arrhenius equation? We know that log k, correct, is equal to minus EA by 2.303 R, correct, 1 by T plus log A. This is the equation. Remember? Okay. Now, listen here. We know that this is similar to y is equal to mx plus c. I have described this in our theory session. Please remember, recollect it. Okay, now if you see here, it's a log k versus 1 by t plot, correct? Log k versus 1 by t plot. So surely if you compare this, we know that k is a variable and 1 by t is also a variable. I am comparing that 1 by t is a variable, I am comparing that to x. So how the graph look like? I will take another color. Okay, so if I draw the graph will be log k. We know that this is log k, correct, and this is 1 by t, and I know that the graph is a straight line, but since the slope is negative here, m is the slope, so we can say it is decreasing in a linear fashion. And what is the slope m here? We know that m is equal to minus ea by 2.303 r, correct? And we know that this c represents the intercept, so here it can be compared with log a, so that means this is the intercept. So intercept here is how much? That is log a. And what is a here? And a represents the frequency factor. So that means if you plot this graph, you will get a, that is frequency factor, and also you will get ea from the slope. So ea is what? Activation energy. ea is activation energy. And you know that r is a gas constant, so that has a fixed value. So very simple, log k versus 1 by t will give you frequency factor and activation energy, correct? So energy of activation as well as frequency factor. So we say option D is the correct answer. So if you have any doubt in this explanation, please ask the same in the doubt clearance group. Thank you.